All right, we're going to talk a little bit about the structure of a plasma membrane. And the things that we need to make sure that we know are what are the components of a plasma membrane, and then we need to be able to define this fluid mosaic model that gives us our membrane structure. Okay. All right, so our fluid mosaic model states that plasma membranes are, well, as, as it says on the tin, they're fluid. Okay, so they are able to change. So they're adaptable. Oh, except for I can't spell. So we can adjust the components, the amount of all these different structures that take them up. We can also modify the location. So if we need to move stuff around, like say this protein, we need it to go over there and do something else over there, we can do that. Okay, but it's this big, and then let's talk about the mosaic component. So the mosaic component of the fluid mosaic model is the membranes are composed of lots of different kinds of biomolecules. Okay, so let's talk about these components then. So first of all, let's remember what phospholipids are. I'm going to try and draw just one here. This is our simplified version. Let me draw the more complicated one here and then I'll erase it. Okay, so we remember we have our glycerol backbone. On two of those carbons on our glycerol backbone, we have fatty acids. And our third, we have our phosphate group. We remember that phosphate groups are negatively charged, therefore they're going to be hydrophilic. Fatty acid tails are composed of just carbon and hydrogens, nonpolar bonds. That makes the fatty acids hydrophobic. So on this one molecule, we have both hydrophilic and hydrophobic portions. Okay, that was a good little review. Get rid of that. Okay, so in our plasma membrane, kind of the foundation are all these little phospholipids. So we have our phosphate head, we have our fatty acid tails, and we might recall from our chapter 3 that phospholipids, when we put a bunch of them together in water, they're going to spontaneously create this bilayer, okay, where we have this layer and we have this layer that are sandwiching together so that our fatty acid tails can be hiding from the water because they're so scared of water. But then our phosphate groups can be hanging out with the water on the exterior of the cell. Okay, all right, so those are our phospholipids. Transmembrane proteins. These are various types of proteins that are going to span both layers. The phospholipid bilayer. Okay, so this protein is sticking out on this side, sticking out in the middle, and we have portions of it that are embedded in the fatty acids. Okay, here's some other kinds of those transmembrane proteins. Okay, they have various types of jobs. Okay, we'll spend a lot of time talking about those. Okay, we're also going to have interior protein networks. So that's going to be these kinds of things that are going to be the anchor points for our cytoskeleton. Cyto, we remember, means cell, and skeleton is what it sounds like. These are the structural components that give the cell its size and shape. Okay, some other things that we have on there are our cell surface markers. So these are going to be proteins that are usually just sticking out on the outside of the cell. This is a glycoprotein. All of this stuff is going to be, we're going to have a sugar protein combo. We can also have lipids that are in the fatty acids that have sugars on them. We can also have these some other kinds of lipoproteins where we have our protein that's embedded in the plasma membrane. We have the sugar molecule, and we have another protein that's sticking onto that. Okay. Also, in addition to those four elements, we also have this other boy called cholesterol. You've probably heard of him because if you have too much of that in your body, it can cause you health problems. Okay, but cholesterol is a ringed lipid. It's a type of a sterol. It's composed of carbon and hydrogens. That better. And we'll talk a little bit about what cholesterol does, but it's an important component of plasma membranes. And that cholesterol, because it's a lipid, it's going to be hanging out with the fatty acids. So this is going to be with the fatty acid tails of the phospholipids. I can't spell phospho for the life of me, so I'm going to spell it as PL for phospholipids. Okay, all right, so that's our mosaic. It's all these different types of molecules that are all shoved together doing the job of preventing unwanted stuff from entering the cell, preventing things that we need from leaving the cell, and allowing things that we do need to enter the cell. So it's kind of complicated, but it's important for